Hello. Thanks for coming. In this talk, I'm going to tell you how we use Kong to improve the resilience of our platform. OLX is one of the biggest sites in Latin America. We get loads of data and a lot of users. First, let me introduce myself. I am a software engineer. My name is Rodrigo Orofino. I've been doing this for almost 12 years now. I'm from Brazil, so sorry about my accent. I live in Rio, the host of 2016 Olympic Games. And I work at OLX. What is OLX? OLX is a marketplace. It's a place where you can sell used stuff you don't need anymore, and you can also buy stuff for a better price, just like Craigslist from the US. OLX Brazil is a joint venture of two of the biggest investors in the marketplace business, Naspers and Adevinta. Adevinta is the lead investor of Leboncoin in France and Avito in Russia. Naspers is the lead investor of OLX in Europe, the whole continent, and also Letgo in US. They are normally competitors, so they are competing around the world, but in Brazil, they get together to build OLX. And because of that, we have the biggest marketplace. We kind of don't have other competitors. We have more than 8 million users actively every month, and more than 70 million accounts registered in total. These are some of our public numbers from 2018. As you can see, we have a very good liquidity. 25% of our items are being sold in the first 24 hours, and almost 65% sold in the first week. We are also the #1 place to sell your car in whole Latin America, and also your phone. So we don't trade in our phones how you guys do it here. In Brazil, you normally buy a new phone, and you sell in OLX. It's a little bit late in Brazil right now. It's closer to 9 p.m. But since I started talking, we probably sold more than 100 items. So we sell pretty fast, more than 50 items per minute. And how we keep our platform so fresh is because we get a lot of new ads every day. So we have a little bit more than 500,000 new ads daily. It was not always this good. If you look back 8 years ago, we were pretty small. We have only 150K daily active users. We have sold just a little bit less than 3 million items. It was a huge growth from where we are standing right now. It was over 20,000%. Oops, sorry. The problem is our stack was not ready for this growth, this kind of growth. So we had a lot of problems to scaling to the size we are right now. We started as our company with just a PHP monolith. It had a proprietary backend written in C by another company from Adevinta, a company called Blocket. It's a Swedish company. They started building it in 1996. So when OLX started, it was almost 15 years old. As you may notice, we were handling session pretty badly. They were storing it in memory by the PHP app. By the time, it was not a big problem because most of our features didn't require login. We didn't have chat or favorites, premium galleries, recommendation, nothing like that. You basically just need an account for selling an item. So you can log in or register, and then you put your ad there, and you could go log out. We don't need the session anymore. But it started to change when it started growing. When Naspers and Adevinta came together to build OLX, they decided to get in the mobile market. So they asked the tech team to build a new mobile solution as fast as they could. So they did it. The tech team put together a new API and built the clients. This API was talking to the same monolith, so it was using the same strategy and solved the problem, right? Nope. Turns out we didn't have features that were good enough to be on the mobile market. So we start writing new features, getting new product managers, and they start thinking outside the box. We keep growing. We develop a set of new features, and this time a lot of the features did require authentication. So one day we hit another problem. This time the problem was a little bit bigger. Scaling was complicated. Why? We were still storing sessions in the PHP app. So using a load balancer was not as easy as it should. And because of that, we kept scaling vertically. So we had an on-premise data center. Every time we need to scale, we just buy a new hardware, put it there. This was not a good strategy. And at this time, we needed to move to the cloud. We need to keep things going. We were spending a lot of development effort, and hiring people is hard in Rio as it is here. So we are wasting good engineers managing infrastructure. So we decided to move to the cloud. And we couldn't do that anymore. So what we did, we decided to use session sticky or session pinning. Well, it's basically a strategy to make sure the load balancer would prox all requests coming from one specific user to the same server instance. And how we did that, we basically ping the session to the user when they log in. So when the guy log in, we save a cookie in his browser or something on mobile app. And now every time the user makes a request and it goes through the load balancer, we would redirect it to the same instance. Again, solved, right? Easy. Nope, we just changed our problems. In a few months, mobile became our #1 platform. We have 4 times the number of users in mobile than we had on the web. But the experience for mobile users were terrible. Sessions used to last a lot longer in mobile. People are not used to log in every time they need to use the app. But we are still using the same strategy to just stick the sessions to the user. So in a few months, we got a lot of bad reviews on the App Store. So it was a problem. Business was not happy about that. Product also was not happy. So we just developed new problems. The problem was sessions were being lost every time one of the server was terminated. So when users that were logged to that session, or to the server, just were logged out. Hence, giving us a lot of negative reviews. In the cloud, it should be easy to scale out and scale in, so we are always putting stuff in new instance in the cluster, removing it, and when we remove that guy, everybody gets logged out. So, big problem. Increase the traffic was also hard for our servers because we are not rebalancing the requests. When we put a new instance in production in the cluster, only new users would be redirected to there. So we could not distribute the requests evenly. So it was not really elastic, by the way. So we also had a huge code base. Everybody was working on the same repo. So everybody was having to use DevBox by this time. We have a lot of external dependence, people using different stuff there. So developer experience was bad when you couldn't run the test on your server anymore, on your machine. You had to run it in our Jenkins. And tests would take like 2 hours to finish. So a long feedback cycle. So you could finish your feature, try to put it in production, open your merge request, and discover that it would break something 2 hours later. And we also had a bad cycle time. Why? We were deploying only twice a week. And normally, one of these deploys would be hold it back or cancel because one team would find a problem and it would be easier to just take everything out. So, as a lot of the developers were really frustrated and the C-level decided to make a change, they decided to split our tech team into product teams and migrate everything to microservice. They also decide that you would start using the T-shaped engineering model. So we would have multifunctional teams and handle the whole development lifecycle. So we would think it, build it, and run it. One of the first teams that was ever created was the accounts team, with the mission to decouple authentication and accounts endpoints from the monolith. How? Using the ice cream scope strategy. Each team should remove their parts from the monolith, so we would break the monolith part by part, and the team should go there, discover what is responsibility, take it out, make it work, the monolith work using the new microservice. And it was pretty important to nothing could be broken because our end user could not suffer. We already had a lot of bad reviews on the store, so it was not a good time. This way, we could gradually migrate over to microservice without affecting our uptimes. This was our first attempt. We started creating 2 new microservices, one for handling authentication and other for accounts information in general. The auth service obviously was responsible for authentication. He was our new identity provider. And we were using a Redis to store the sessions. So we had the keys was the session ID, and the values was the logged user information. And again, things started to look good again. We could scale horizontally again, no problem with the APIs. Everything looked great. Business kept growing. We kind of doubled the number of our users from one year to the other. And then we hit the proliferation of microservices. Now we were more than 100 engineers dividing into 20 teams. Everybody was using whatever the technology they want, so a lot of different language. Each team had their own set of microservices, normally 2 or 3. So in just a few months, we went from this, our first attempt, to this. Everybody built their service, and sometimes they need authentication. So what they would do, they see how we do this in the monolith and copy it. So everybody's calling auth service direct. It was chaotic. Auth service was receiving almost 1 million requests per minute, and it was not handling it very well. Costs increased a lot. We are expanding more than $7,000 monthly. We are using 28 C4X large instances in production. Our Redis was up to 60 gigabytes of memory. Performance was terrible. An average request to auth service would take 40 milliseconds, with more than 5% of these requests taking longer than 100 milliseconds. Incidents in production were a lot more common than we were comfortable with. A lot of the times it was related to that Redis. That was a single point of failure when things went wrong there. Sometimes we just lost all the sessions and everybody was logged out from the platform. And why that was happening? We had a huge volume of requests in auth service. And sometimes we had request duplication, because if 2 different microservices needed to make sure a user was logged in, they couldn't make sure that the guy was authenticated, so both would call the auth service for the same request coming from the end user. So a lot of request duplication. We also had tight coupling. Every service was calling our microservice directly. So improving anything off service was hard because we had like maybe 50 different services using it. So it's hard to coordinate the effort to everybody make updates. So we also had a lot of code duplication, a lot. Every microservice had the same authentication logic. When a microservice needed to make sure a user was authenticated, he would make a request to auth service, passing the session token. So first security problem there. They would check the response. If it was not valid, it should return 401. Also, if the request was coming from a web browser, the responsibility of the team to make sure the right redirect flow would work. So they would come up with some different strategies to do that. We were also not fault tolerant. Any problem in the Redis was a downtime for us. We had nothing we could do. And after seeing this all, we had to accept that our system design was just bad. It was not going to work for us. So we got back to the drawing board. This time we had new requirements. We need to keep things backward compatible. We needed better performance. We need to be more resilient. We need to avoid code duplication for the other teams so they could iterate faster. And last but not least, we can't lose the access to revoke. We can't lose the ability to revoke access fast. So it means we can't go full stateless. It's a huge trust and safety issue for us. So it was time for a new strategy. And after studying the problem again, we come up with one. First, we created a new identity provider. This time, we would persist the token data in a database, not just in the Redis. We would use the Redis just as cache layers to avoid reading from database all the time. We also choose to move to a different strategy. We would use two different kinds of tokens, a short-lived stateless token and a stateful refresh token. And of course, this time, we use an API gateway. After 2 weeks experimenting with some guys, we decided to go through Kong. And I think in 1.5 weeks or something like that, we had our first Kong cluster in production. And we were proxying all our requests through it. Kong has a lot of nice built-in plugins. We are still using some of them. But we tried to use them for our use case for authentication, but we need to keep things backward compatible, and OLX was not using any kind of standard for that, so we had a proprietary stuff. So we decided to build our own plugin and make use of one of the good characteristics of Kong. It's easy to extend Kong with plugins. These are the options of the plugins we built. As you can see, you have a few choices you can make here when you're adding a route to Kong. The most important options is authentication optional, and what accounts information do you need. So if you need the email from the logged user on your microservice, you would put that there. Also, anything you need. So we would take care of just getting it up to you. Now I'm going to show you the flow of a request that passes through Kong using our plugin. So first, the request comes from the web browser or mobile app. So it's coming directly from the client. It hit Kong's. Kong check if the route being accessed has the plugin enabled on it. If it has, it will start running the plugin. The plugin will check if the route you are accessing needs any account information. If you need any information other than the account ID, we will make a call to account service to fetch it. In parallel, we validate the stateless token. So if the token is good, we don't need to do anything anymore. But if the token is not good, we call auth service passing the refresh token. So we now get a new stateless, short-lived stateless token. Then we return it to Kong. Kong injects this information in the upstream, in the headers for the upstream. So we get all account information that you need there, and procs the request to the upstream. Now the upstream can easily read the information they need from account from the header, so it's easy to do it in any language, so we don't have problems with that. The microservices do whatever they need to do and return to Kong. Kong now includes the new stateless token, if he got one, to induct the request and return it to the client. But what happens if the user is not logged in? Well, if the user is not logged in, we have a few conditions. We have a few different cases. Remember this screen? The first thing you can check here is if the route is, the authentication is optional. If it is, we don't need to do anything. We just don't put any information on the header, so the microservice can know the guy is not authenticated. If you keep that as required, and you did not turn on the redirect feature, it will just return 401. So what we normally do, we put APIs for mobile without this option, and when we are using it for the web, we turn on this feature. If the redirect feature is turned on, the plugin has another job to do. It will generate a JWT or JAW for the request, mainly the HTTP verb method and the body. So then it will redirect the user to the login page, but this time passing this JAW in the query stream. So after the users log in, the accounts team can take care of the redirect flow for you. We just need to reprocess the JWT or JAW, and we take care for the whole redirect flow for you. So the team doesn't need to think about it anymore. Let's talk about the results. First, we saw a nice reducing cost. This is the total cost for the Kong instance and the new identity provider server. We are using AWS ECS, so we are running everything as a container now. We reduce a lot of the requests because we eliminate the duplications, and we also using the stateless token, so we are avoiding calling the new identity provider all the time. So we don't need a lot of instances anymore. We are just using C5 large instance. This time is C5 large, not X large, a big difference. We also using the Redis only as cache, so we don't need more 60 gigs of memory anymore, just 15. So we save a lot of money there. We also include the RDS to store Kong information and our tokens for the identity provider. But this RDS was not getting a lot of reads because Kong is pretty efficient to cache the service and routes. And we are caching most of our requests to refresh tokens in this Redis, so it was not a big deal. We also saw a nice boost in production. Performance increased a lot. It takes less than 10 milliseconds to authenticate a request now. Only request that needs a lot of account information gets delayed, so if you need only the account ID, we normally can do that in less than 3 milliseconds, so we kind of made the whole platform faster. Uptime also improved a lot, but let me just say first, this is not the uptime for OLX in general, it's just for accounting the authentication flow. So, as you can see, it got a lot better, and mainly because now we have fallback strategy when things go wrong. We don't need to upset our users every time. So we also could implement another fallback strategy, some kind of battery pattern. So we could extend the duration of the stateless tokens if things get really bad. So it's a really huge emergency, we could just turn on a flag and say, okay, everything now is valid for 1 hour, and we can buy us some time to make things get back up. So another nice benefit was better API management. Right now, we have a little bit more than 50 service registry in Kong using the plugin, but we have hundreds of services, and we are making use of the concept of consumers in Kong to put teams in there. So we register all teams as consumers in Kong, and we gave them different API keys. So every time they call us, they call passing an API key. And now we can put in place some rate limit policies and also a little bit of ACL. So it was nice. Also, lastly, but it helped us a lot with observability. We came from this level before. This is the total of requests to the all service load balancer. As you can see, it was close to 1 million requests per minute. And it's all we could see to this. Now, we know which teams are clients of our service, how long they take to respond, if they are closing to exceeding rate limit, the response status code that they are giving us, all this good stuff. Debugging became a lot easier, and it was just using the built-in plugins. We didn't have to do anything other than just enable it, so it was awesome. I think we have time for a few questions. If anybody has any question? No? Okay. Oh. Can Sorry, I can't hear you.
For your Kong gateway, what kind of HA deployment do you have?
What kind of what?
For Kong gateway,
Yeah.
what is your HA deployment?
How do it? How do we deploy it? Okay, we are running AWS ECS cluster. We're managing the cluster by ourselves using Lambda functions to scale in and scale out. So we deploy it as a container right now. So we have a cluster for the accounts team. Before that, we were experienced using EC2. The first time we put everything in production, we just used EC2. Use Packer from HashiCorp to build the AMI, and we are using Terraform integrate with our CI and CD to deploy it. So, but after some time, we knew we would migrate to Docker. We had a Kubernetes cluster right now, so we started to migrate everything to containers, and we used ECS as a temporary solution until our cluster was ready. Any more? Oh. I hope you enjoy it. Thank you. Obrigado.